video is on finding rates of change and slope. It's lesson 41 in your book on pages 260 through 262. A rate of change is a ratio that compares the change in one quantity with the change in the other. Now, we know that the word ratio means we're going to have to divide, and in this case, we divide the change in one quantity by the change in another. For example, the speed of a car is a rate of change, because in order to find the speed of a car, you divide the distance it travels by the time it takes the car to travel that distance. Here we're going to find rate of change from a graph. This is an example and it needs to be in your notebook. So we have a graph here, and a car is traveling on a highway at a constant speed. The graph shows the relationship between the distance traveled and the time traveled. Find the rate of change. Now, in order to find the rate of change, RC, we're going to need to divide the difference in the dependent variable by the difference in the independent variable. So in this graph, we have time in hours and distance in miles. Now, because how far we travel depends upon how long we are traveling, our independent variable down here is time, and our dependent variable is distance. Now we have 2 points marked here. We know that at 1 hour, the car had traveled 60 miles, and then we also know that at 2 hours, the car had traveled 120 miles. Now, in order to find our rate of change, we're going to have to use these 2 points and find the difference in the dependent variable, or the distance, and then divide that by the difference in the independent variable. So, we know that at point 1, I'm going to call this point 1, the distance the car had traveled was 60 miles. And at point 2, right here, the distance the car had traveled was 120 miles. Now, that's the difference in our dependent variable. Now we need to find the difference in our independent variable, or our time. At point 1, our time was 1 hour, and at point 2, our time was 2 hours. Now we need to simplify this to find our rate of change. So 60 minus 120 would be negative 60, and 1 minus 2 would be negative 1. Now negative 60 divided by negative 1 is a positive 60. So our rate of change is a positive 60. Now we also have units for our rate of change. Our distance in miles was our numerator, so it's miles on top. Our time in the denominator was in hours. So our units are in miles divided by hours, or miles per hour. Here we have a table, and we need to find rate of change. This again is an example that needs to go in your notebook. A shop charges a fee for renting kayaks. What is the rate of change for the rental fees? Now we have 2 variables here, the time in hours and the cost. Now when you're renting something, how much time you borrow it determines how much you will be charged. So cost depends on time. So cost is our dependent variable, and time is our independent variable. Now in order to find the rate of change, we need to take the difference in the dependent variable and divide that by the difference in the independent variable. So I can actually use any 2 of these points that I choose. Now I think I'm going to use this point as my first point and this one as my second point. Now it doesn't matter which 2 you choose as long as you stick with those 2. So my dependent variable is cost, and I'm looking for the difference in my cost between these 2 points. So I have, in my first point, the cost was $60.50. At my second point, the cost was $88.50. That's the difference in my dependent variable. In my independent variable, my time, my first point, the time was 4, and at my second point, the time was 6. Now I just need to subtract these two. So 6050 minus 8850 would give me negative 28, and this is dollars. And 4 minus 6 would give me negative 2, and then this is in hours. Now, negative 28 divided by negative 2 gives me a positive $14 per hour. So the rate of change for the rental fees is $14 per hour. They will charge you $14 for every hour that you rent the kayaks. Now, rate of change and slope of a line are related. The slope of the line is the rate of change in that line. And I know you guys know the song, slope is easy, slope is fun, slope is rise over run. I'm sure Miss Brinkley has made you sing it a million times. Now, the rise is actually the change in the dependent variable. So that is the change in, this little triangle means change, in the dependent variable, or the y values. And the run is actually the change in the independent variables, or how did the x values change. So it's the same concept. We just use rise over run when we're talking about a graph. So if we want to find slope from a graph, all we have to do is find rise over run, and it's really handy when we have a graph because we can count. So here we have this graph, and we want to find the slope of this line. So we know that our formula for slope is rise over run. Now, if we're talking about this point here, 0, negative 1, and this point here, 4, 1, and we're going to count the rise, we would count up 1, 2 units. So our rise is 2 units, and then our run to this point is 1, 2, 3, 4 units. So rise over run is 2 over 4, and of course we always want to simplify 2 over 4. Those are both divisible by 2. So we end up with 1 over 2. So the slope of this line is 1/2. And it's positive because this line is going uphill from left to right. Now in this example, which needs to be in your book, we have another line and we want to find the slope. So we have a point here on the line, 1, 1, and then we have another point down here on the line, which is 4, negative 8. Now to find the slope of this line, again, we do rise divided by run. Now, from this point to this point, we are rising, but we're actually rising down, right? So we're going in the opposite direction of rising, so our value is going to be negative. And so we have 1, and then 2, 3, because each of these marks are 2, 4, 5, 6, 7, 8, 9. So our rise is actually, we're going down 9. So that would be negative 9. And then our run, again, each of those lines is 2, so our run would be 1, 2, 3. So our rise over run would be negative 9 over 3. And of course we want to simplify. Negative 9 divided by 3 is negative 3 over 1, or just negative 3. So our slope here is negative 3. Now, horizontal and vertical lines are a little weird. So the graph of the equation y equals c, where c is a constant, is a horizontal line. So whenever you have y equals some number, your graph is going to be a horizontal line. The slope of a horizontal line is 0, and here's the reason for that. This horizontal line has no rise. It does have an infinite run, though. So we could say the slope of the horizontal line is 0 over some number. And we know that 0 divided by any number is just 0. Now the graph of the equation x equals c, where c is a constant, is a vertical line. Now that means if you have the equation x equals some number, that will be a vertical line. The slope of a vertical line is undefined. The reason for that is that this vertical line does have a rise, so it will have a number as its rise, but it doesn't run to the left or right any at all. So it's a number divided by 0. And since we can't divide by 0, the slope of a vertical line is undefined. Now here we're given instructions to find the slope of this horizontal line. This is an example, it needs to be in your book. Now, notice that the rise between 2,4 and 6,4 is 0. We have gone up 0. But the run between 2,4 and 6,4 is 2, so we're at 1, 2, 3, 4 units. And 0 divided by 4 is 0. And the slope of any horizontal line is 0 because there is no rise. Here we need to find the slope of this vertical line. Again, an example that needs to be in your book. Notice that our rise, we actually do go up some units. We go up 1, 2, 3, 4 units. But we don't run to the left or to the right at all. So our run is 0, and 4 divided by 0 is undefined. And here we have our last example that needs to be in your notebook. The graph and the table show the relationship between the number of servings of a salsa recipe and the ounces of black beans used to make the recipe. We want to find the rate of change. Now, we can either use the graph or we can use the table to find the rate of change of this. The graph makes our life a little easier because notice that it has a number of servings in the x-axis. That is our independent variable, our x-axis. And it has black beans as our dependent variable. Because it's hard to find rate of change if you don't know which is your independent variable and which is your dependent variable. Now they're saying that you decide how many servings you want and then you use the appropriate number of black beans. So to find the rate of change, we need the difference in the dependent variable divided by the difference in the independent variable. And we have 2 points marked here. We know that for 6 servings, we will need 15 ounces of black beans. And we also know that for 18 servings, we will need 45 ounces of black beans. So I want to find my difference in my dependent variable here. So 15 and 45. And divide it by the difference in my independent variables, so 6 and 18. Now 15 minus 45 is negative 30, and 6 minus 18 is negative 12. And I want to simplify this as much as possible. Now, of course, my negatives cancel. Negative divided by a negative is a positive. And these two numbers are both divisible by 6. So 30 divided by 6 would be 5, and 12 divided by 6 would be 2. So my rate of change here is 5 over 2. Now I also need units. So my units were ounces on the top and servings on the bottom. Okay, so that means I need 5 halves ounces per serving, or 2.5 ounces per serving. And that is all.